Welcome back to the deep dive. Today, our whole mission is to, cut through the noise around distributing complex RF signals. We're talking about satellite and terrestrial TV and how to do it better.
Right.
And for that, we're looking at the Thor Broadcast F-SattGalaxy-TX RX-3 system. The first thing that jumps out is, well, it's a total game changer. It takes all these big, heavy coaxial trunk lines and replaces them with just one single strand of optical fiber.
It's a huge shift. I mean, the core problem the system solves is bulk and distance, both at the same time.
Okay.
It takes 3 separate RF inputs. So think 2 L-band signals from your satellite dish and 1 regular off-air antenna signal, and just bundles them all together using light.
So for a big building or a campus where the dish is way over there and the equipment room is way over here, this gets rid of all that expensive coax.
Exactly. Those long, costly runs just disappear.
All right, so let's dig into that signal stack. You've got the 2 satellite L-band inputs. And just to be clear for everyone, when we see acronyms like VL, HL, VH, HH, those are the specific quadrants of the satellite signal, right? Polarization and frequency.
That's it, precisely.
Yeah.
If you're using a quad or a quattro LNB, you have to deliver those 4 distinct signals. Vertical low, vertical high, horizontal high.
Right.
This system is built to pipe all 4 of those through. But the really fascinating part, I think, is that third port.
The terrestrial one?
Yeah. It can handle pretty much any broadcast standard you throw at it. ATSC, DVB-T, even old NTSC, or cable QAM.
Wow.
The frequency range it covers is just massive. We're talking 47 all the way up to 2,150 megahertz.
Okay, that's a staggering amount of spectrum to put on one tiny piece of glass. How do you cram all of that RF energy onto a single fiber without it all just turning into a mess of interference?
That is the engineering magic trick. It's something called CWDM, or Coarse Wavelength Division Multiplexing.
Or CWDM.
So instead of trying to filter electrical signals, you just separate them by the color of light. It's a much cleaner way to do it. The system uses multiple lasers, and each one is tuned to a very specific wavelength, a specific color.
So each signal gets its own private lane, its own color.
You got it. For this whole stack to work, we actually need 5 separate wavelengths. 1 for VL, 1 for HL, 1 for VH, 1 for HH, and then a 5th one just for that terrestrial feed.
So wait, 5 separate high-capacity pipelines of light are running inside that single fiber just to handle 1 satellite feed and 1 antenna.
That's CWDM in a nutshell.
That sounds incredibly efficient, but I have to ask about the practical side. I mean, fiber can be tricky to work with compared to just crimping a coax connector.
It does require more attention to detail, for sure.
Yeah.
It has to be single-mode fiber. It won't work with multi-mode.
Okay.
But the system has some really smart engineering built in to make it reliable. For instance, it uses what are called SKC-PC connectors.
The green ones?
The green ones, yeah. Their tips are angled polished, and that angle is critical because it basically eliminates signal reflections. You get a much, much cleaner connection. And maybe, most importantly, it has built-in automatic gain control, or AGC.
And that just keeps the signal level stable.
Perfectly stable. It locks the output at 75 dBV, plus or minus a tiny bit. That cuts way down on service calls for signals that are too hot or too weak.
And that stability is key when you start scaling up. We're not just talking about one connection rate. This is for point to multipoint.
Oh, absolutely. You can run these systems as 1x4, 1x8, all the way up to 1x32.
So one transmitter can feed up to 32 different optical receivers.
Up to 32, yeah, all within about a 10-kilometer radius.
Which connects right back to what you're saying about large buildings.
Exactly. This is the ideal setup for an apartment complex or a hotel. Each of those 32 receivers can then feed a local multi-switch system. When you do the math, you could be serving, well over 1,000 individual apartments or rooms from a single dish.
And for the installer, the transmitter doesn't even have to be mounted right by the antenna. That must make designing the head end a lot simpler.
It's a huge convenience.
So when we boil it all down, we've taken this incredibly complex bundle of RF signals, and by using CWDM, we've neatly stacked them onto 5 different colors of light, replacing all that bulky copper for a really stable, long-distance delivery.
It's an elegant solution. So here's a final thought for you to chew on. Considering you need all those signals, the 4 L-band quadrants, the terrestrial feed, just for one service, how fundamentally different is the mindset when you realize you're designing media distribution not by managing electricity, but by managing the color of light?